climb now, flight level 210.
Unmanned aircraft are really the next exciting stage in aviation, and ASTRAEA is bringing that to reality. Manned aircraft have been evolving over the last 100 years, and you could imagine that where we are with unmanned aircraft is at the same stage that Henry Ford was with the Model T back in 1914, and we're right at the beginning of that journey.
In the same way that manned aviation blossomed through the 1920s and 30s, we'll see unmanned aircraft business blossoming in the 2020s and 2030s.
This is probably at least as significant as the introduction of the jet engine into commercial airlines.
We've got used to a level of automation and intelligence in many of the objects that are around us today, and we can see that increasing into even our cars. We can see the need for much larger aircraft that can fly over much longer distances and for extended durations, delivering these sorts of services in a much more affordable and less intrusive fashion.
Airliners used to take 4 or 5 people as a crew, and as technology has advanced, we're now down to 1 or 2 people. What we're talking about is the next step, and whether that's taking the pilot out of the cockpit or giving him a reduction in workload so he can concentrate on the important things in the mission, our system is certainly moving that forwards.
We've invested billions into UAV technology, whether it's the actual product itself or the kit that's in it, the intelligence of the autonomous system. So we wanted to be able to understand, when we take that and apply it into new markets, what's that worth? And that study showed that the estimates are worth £265 billion a year. And those applications are in a complete broad range of sectors. We don't know about the applications of the future, and this has the possibility of really being revolutionary for UK business.
ASTRAEA has been going for the last 7 years. It started in 2006, and we've spent some £62 million on the programme to date. ASTRAEA is looking at the technologies, it's trying to understand the regulatory framework, and it's also trying to understand the procedures that will have to be used, for instance with air traffic controllers. We have a world-class team of companies involved in the ASTRAEA programme who can address all aspects of the technologies required to open our airspace to unmanned aircraft.
ASTRAEA is definitely one of the first programmes that has done this end-to-end research, looking at not only the technologies but also the people involved.
To improve the utility and the safety of unmanned aircraft, we've been working on and developing autonomous systems, in particular decision support tools that aid the pilot, increase the levels of awareness and allow the pilot to concentrate on commanding and delivering the end product and not so much on having to fly the aircraft itself. This morning we were testing the system, showing that we could communicate from the ground to the aircraft, set top-level goals. Once en route, we could direct the camera to point at various aspects on the ground.
Yesterday's test flight was from Wharton up to Inverness, and the vehicle was being controlled via a ground control station here at Wharton.
Accelerated with 180 knots for the handover.
Okay, GCS, confirm you're ready for handover brief.
All copies, ready to take control.
And proceed.
LOA 4, I have control.
You have control.
The pilot was interacting with air traffic control as if he was sat in the aircraft.
We have one particular goal in mind, and that's to allow the pilot to be able to command one or more aircraft in much the same way as they would interact with a human team.
We're developing communication systems for the safe operation of a virtual network between these various classes of unmanned aircraft.
We need to make sure that the power system is looked after from a health point of view, so if something goes wrong, the system can look after itself and self-heal as well. For self-healing systems, we can certainly see a spin-off into manned aircraft. The pilot knows he's got a system that can reconfigure around potential problems.
We've been working on this since really the onset of ASTRAEA back in 2006, and we've pretty much focused our activities into coming up with a detect and avoid solution. It provides the necessary level of situational awareness to guide the UAV without risk of collision with other airspace users or indeed the terrain itself. What we're effectively trying to do is mimic the pilot in the air with a view to migrating the capability onto a UAS in the near future.
The technologies that we will have to use to do that will also have application back in manned aircraft, and there is reasonable hope that these will improve the safety of manned aviation as well.
The point of air-to-air refuelling is to enable an aircraft of any type, be it manned or unmanned, to fly longer, and therefore what's commonly termed as persistence. Pilots who I've spoken to have said the refuelling manoeuvre is actually rather challenging. Trying to replicate it with technology has taken a significant team and all their combined brain power to work out how to do this.
The ASTRAEA programme throughout its 6 years has worked principally with the UK Civil Aviation Authority, but we have had engagement with other regulators as well. One of the significant moments we had in ASTRAEA was developing a virtual certification process with the CAA. We've taken a Jetstream 31 and developed all the certification documents that you would require to create an unmanned aircraft of that class.
It's actually a very structured and gradual process, and that's important because we need to show people at large and the authorities that we're safe to operate, showing that we can integrate unmanned aircraft into airspace in a manner that's transparent and equivalent to manned aircraft, but equally to show that we're adding value, otherwise there's no point in doing this, and that's the ultimate end goal.
We have to make sure that the insurance industry understands the implications of it, that legislation is appropriately put in place to control the use of these things so that they don't have unintended impacts on society. And so it's all of these aspects that we need to consider and get ahead of the game, so there needs to be plenty of consultation with the public and understanding of what benefits these unmanned aircraft can bring to the wider society.
We can see lots of utility for unmanned aircraft in a number of market areas, be that agriculture, fisheries, energy, environment, telecoms and emergency services.
Looking for people far out at sea or staying up for, say, 24 hours in Snowdonia, irrespective of the weather and conditions.
I don't actually see them taking over things like passenger flying. Why would they? There's no need to. I don't see them replacing manned aviation completely. It has no need to. I see it as complementary.
Estimates vary, but certainly before the end of this decade, I'm sure we'll see unmanned aircraft in quite a lot of applications. I guess in 20 or 30 years' time, we won't refer to unmanned aircraft, they will just be aircraft.